Bismillahirrahmanirrahim. How are you, students? Today we will start a new chapter, and the name of this chapter is for motion and force. You already know about motion and force. We will revise it a little better. So, motion and force. First, we will define motion. The body is said to be in state of motion if it changes its position with respect to its surrounding. If a body changes its position, changes its position changes position changes position with respect to its surrounding. Changing position with respect to its surrounding, it is called motion. The with this we also study rest. Does not change its position. Does not change its position. Does not change its position. These are called state. Motion is state. Rest is state. State is situation. State is situation. A situation in which a body is likely to be found is called state. So, state of rest and state of motion. Force. Anything which produce acceleration. Which produce acceleration. So, anything which produce acceleration is called force. Push or pull. Push or pull. Push or pull is called force. Force is an external agent capable of changing the state of rest or motion of a particular body. If a body change, if if you apply, if you push or pull a table, and if you change its position from rest to motion, then that agent or external agent is called force. It has magnitude and direction. It has magnitude and direction. Direction will be the direction of force will be in the direction of application, or the force will have direction in the direction of motion. The directions towards which the force is applied is known as the direction of the force, and application of force is the point where force is applied. The force can be measured by spring balance. Unit is Newton. Unit of force is Newton. Displacement. The shortest distance from the initial to the final position. Displacement is defined as the change in position of an object. It is a vector quantity and has a direction and magnitude. This is one point. This is the other point. If a body moves in this direction, if a body is moving in this direction, and then the body is moving in this direction from point A to point B and then to point C. This is the actual path. Actual path. This is the actual path. So the actual path traveled by a body is called distance. It is distance. And the shortest distance between this point and this point is this one. This is the shortest distance. It is called displacement. Shortest and directed. If the shortest and directed distance between point A and point C is called displacement. The actual path traveled by a body is called distance. Distance is a scalar quantity. Displacement is a vector quantity. Now, you can see in the given diagram, the body traveled the dotted line, this line. This is the distance. This is the displacement. This is the displacement. This is the shortest distance. And this is the actual path traveled by a body. So this is distance and this is displacement. Distance is scalar, where displacement is vector. If a body starts from point A, goes towards point B, then goes towards point C, then goes from C to D, and then back to point A. The shortest distance between point A is the initial and final point. The shortest distance is displacement, which is zero in this case. And distance traveled by the point is 5, 3, 5, 3, 5, 5, 10. It's 16. It's 16 meter. So the actual part traveled by a body is called distance and it is 16 meter. But the displacement is zero because the initial and final point is same. So displacement is zero. Distance. Distance is the length of the path traveled by a body while moving from an initial to a final point. This is the distance, actual path traveled by a body. This is the shortest distance. Displacement is a vector. Distance is a scalar. Distance measured is always positive. Distance measured is always positive. Distance always, displacement can be positive or negative because displacement is a vector quantity. So it have both positive value and negative values. And distance is always have no direction. So it have positive values. The total distance covered is equal to the algebraic sum of all the distances traveled in different direction. The net displacement is the vector sum of the individual displacement in different directions. There is always a distance covered whenever there is motion. Displacement will be zero if the body comes back to its initial position. Unit of displacement is meter and the unit of distance is also meter. Now, next is velocity. The speed of a body in a definite direction. The speed of a body in a definite direction is called velocity. Speed is distance per unit time. Speed is distance per unit time. Velocity is displacement per unit time. Displacement per unit time. Velocity is vector. Speed is scalar. Displacement covered by a body in unit time is called velocity. Velocity, velocity. Velocity is the displacement per unit time, the rate of change of displacement, and speed is distance per unit time. Speed is scalar, velocity is vector. Uniform velocity. If a body covers equal displacement in equal interval of time, if a body covers equal displacement, equal interval of time, equal displacement in equal interval of time, then it is called uniform velocity. A body, when a moving object travels equal displacement in equal interval of time, then it is said to be in uniform velocity. Non-uniform, variable velocity. Unequal displacement covered in equal interval of time, or equal displacement in unequal interval of time. One must be unequal. If a body covers equal displacement in equal interval of time, it is called uniform. If it covers unequal displacement in equal interval of time, it is called non-uniform velocity. Average velocity, if an object or a body is moving with a variable velocity, then the ratio of total displacement to the total time taken. So total displacement, if total displacement in total interval of time taken is called average velocity. This is the graph, AB graph. This graph represents a variable velocity, non-uniform velocity, non-uniform velocity. So if a body covers equal displacement in equal interval of time, displacement is equal, time interval is equal, uniform velocity. Unequal displacement, unequal interval of time, or equal interval of time but unequal displacement, non-uniform, average velocity. Total displacement covered by a body in total interval of time taken. Now next is instantaneous velocity. The velocity of a body in a very short interval of time taken. So if a body The velocity of a body at any instant of time is called instantaneous velocity. It is the velocity of a body in a at any instant of time is called instantaneous velocity. Very small interval of time. Velocity of a body in a very small possible interval of time. Velocity here, the definition of velocity for you, velocity, average velocity. So this is the revision a little bit. Types of velocity. This is called instantaneous velocity and average velocity. So if you take at 0.1 second, the velocity is 40. This is instantaneous. If you take 0.5 at this interval of time, velocity is 40. So the velocity of a body in a particular interval of time is called instantaneous velocity. Here the velocity is uniform. Here the velocity might be instantaneous. Here uniform velocity. Here decreasing velocity. If you take sum of this velocity, all these encircled values, and divide it by time interval, then it is called average velocity. So total velocity of a body, if you take average, if you take total displacement divided by total interval of time, then it is called average velocity. This is the graph. In this graph, velocity is uniform. Here the velocity is uniform. Increasing velocity. Here velocity is increasing because the graph is between velocity and time, so it is increasing. The graph is between velocity and time, so it's uniform. It decreasing velocity, increasing, uniform. This is the graph between velocity and time, increasing velocity, variable velocity. Here increasing, uniform, decreasing, uniform, increasing. At v is equal to 0. This graph is between time and displacement, so velocity is 0. This is for a body which is in state of rest. Velocity is 0. This is the graph between acceleration and time, but the body is at rest. So 0 velocity, 0 velocity, 0 velocity. Motion with constant velocity. Displacement, time, constant velocity. Constant velocity. Between velocity and time, acceleration and time. This is a mistake. This is 0 velocity, rest. Now, motion with constant acceleration. Displacement, increasing velocity. Velocity changes. Velocity changes. Equal change. Here, equal change. Now, motion with constant deceleration. Here, the acceleration decreases. Acceleration decreases. Velocity decreases. Velocity decreases. Here, body is moving with an acceleration, with constant acceleration. So velocity is uniform. Velocity is uniform. Change in velocity is 0. So in both these cases, the velocity is uniform. Velocity is uniform. Newton laws of motion. Newton first law. An object in state of rest will try to continue its state of rest, and an object in state of motion will try to continue its state of motion. Newton first law consists of two parts. If a body is in rest, it will remain in rest. And if it is in motion, it will remain in motion if no force is acting on that body. If you exert force on a body in state of rest, it will change its state. So if no force is acting, the body will try to continue its state of rest. And the property due to which it opposes any change, opposes change of state, change of state. It is called inertia. So Newton's first law is also called law of inertia. Law of inertia. Greater is the mass of an object, the greater the amount of force is needed to accelerate it. This is second law. F is equal to ma. We stated if 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 we apply force on an object, it will produce acceleration in the direction of force, which is directly proportional to the magnitude of force and inversely proportional to the mass of an object. First law, explaining the state of an object. If it is in rest, it will remain in rest. If it is in state of motion, it will try to continue its state of motion. A book lying on a table will remain in state of rest, will remain on the table if no force on it. If, if you exert force, it will produce acceleration. If you exert more force, more acceleration will be produced. If you increase the mass, keeping the force constant, the acceleration decreases. Newton's third law. For every action, there is always equal but opposite reaction. Action and reaction are always equal but opposite in direction. So force of action is equal to force of reaction. Third law, we will study in detail also. Now, first, every object persists in its state of rest or uniform motion in straight line unless it is compelled to change that state by force impressed on it. Initial condition. Kite in stable flight, zero vertical velocity, lift balances weight and vertical. If it is in balanced condition, upward force will be equal to lift, which is called lift, will be equal to weight of an object. But if wind increases, lift depend on wind speed, lift increases, force is unbalanced, kite climbs positive vertical motion. If you increase the wind up speed, the upward force increases. So the kite will move in the upward direction. Tension in line increases. Vertical pull depends on line of tension. Vertical pull increases, force balance, zero vertical velocity, kite in new stable state. If vertical push in the upward direction is equal to the downward, it will be in balanced condition, otherwise not. Now, here an object in state of rest. Here an object in motion stay in motion at the same speed and same direction. Here, unless it is opposes by this um, obstacle. So you can see the result. Newton's second law. This is force. This is change in momentum divided by this. Force is equal to del P divided by del T. Force, force is equal to del P divided by del T. Del P divided by del T. Change in momentum is del P. With time, this one. Del P is equal to mv, del mv, m del v. We will write this one. Here, I will do it for you people on the next page. Force is mass into acceleration. Force is equal to ma. Force is equal to ma. Force is mass into acceleration. Mass into acceleration. I will explain the previous topic, but we will do first Newton third law. For every action, there is always a reaction. Force of action is equal to force of reaction, but in opposite direction. So a negative sign. Here, ball deflected up, flow deflected downward. Action and reaction. Exerts upward force, airfoil, foil deflected up, flow deflect downward. Engine pushes up, engine push forward, push, flow push backward. If the engine is moving the object in this direction, the resistive forces will be in the opposite direction. Now, F is equal to ma, Newton's second law. F is equal to m del p divided by del t. This is the rate of change of momentum is called force, mv. F is equal to del p divided by del t. Final momentum minus initial momentum. Initial momentum is equal to mvi. Final momentum is equal to mvf. The change in momentum, right? Change in momentum is equal to mvf minus mvi. So del p is equal to m del v. Del p is equal to m del v. The more force, the more will be acceleration. So del p divided by del t is equal to m del v divided by del t. This is force, so write force. Force is equal to m del v divided by del t. Now, we just derived that force is equal to m del v divided by del t, and force is equal to ma, and force is equal to m del p divided by del t. These are different relations. This is Newton's second law. This is definition of momentum. The rate of change of momentum is called force. Newton's second law. In this case, you apply force, mass, acceleration is produced, speed increases. More force, more will be the acceleration. More force, more will be the acceleration. What is momentum? What is momentum? Now, momentum is a physics term. It refers to the quantity of motion that an object has. A sports team that is on the move has the momentum. If a body have velocity, will have momentum. If an object is in motion, then it has momentum. Momentum depend upon variables, velocity and mass. The product of mass and velocity. The product of mass and velocity is called momentum. P is equal to mv, where P represents momentum, m represents mass, and v represents velocity. Momentum is a vector quantity. Unit is kilogram meter per second. So momentum is a quantity, that quantity which increases with increase in mass as well as velocity. So if a quantity increases with increase in mass and velocity and decreases with decrease in mass and velocity is called momentum. In physics, the symbol for the quantity momentum is the lowercase p. Thus, this is symbolic representation for momentum is p, for mass is m, for v is, for velocity v. You read this one. This is written for you people. Now, express the unit of momentum in terms of unit of force. Express the unit of momentum in terms of unit of force. Now, F is equal to ma. The unit of force is Newton. Mass is kilogram, and acceleration is meter per second. Meter per second square. Meter per second square. It's positive. It's a square. Now, write Newton. Here we will write kilogram meter per second square multiplied with second multiplied with second. This is cancel. Here you will write Newton second is equal to kilogram meter per second. I will write again. P is equal to mv. Unit of momentum is kilogram meter per second. So this is the unit of momentum, and we express it in terms of unit of force. So unit of momentum is Newton second, and this is the derivation. A force is required to change momentum. If force acts, it will change momentum, tends to change the momentum. The relation between force and momentum is this one. F is equal to m del v divided by del p. This is in theoretical form. We already verified that del p is equal to m del v. So this is equivalency of this one. Change in momentum. F is equal to ma, second law. This is the definition of acceleration. So F is equal to, by definition of acceleration, we write this. T is multiplied here, ft, m del v. Ft is equal to this one. This ft is called impulse. This is equal to change in momentum. Del, this quantity is equal to this one. So impulse, when a very large force act on a body for a very short interval of time, then it is called impulse. Impulse, when a very large force, very large force applied for a very short interval of time, applied for a very short interval of time. If you push someone, if you kick a ball, if you hit the wall, hammering, these are called impulse. Impulse is the amount of change in an object momentum. Change in momentum is called impulse. Impulse is the product of force and time interval. Force time interval is called impulse. Acceleration is this one. This is by definition. Del v divided by del t is written here. This is divided acceleration according to Newton. This put the value. Mass is multiplied. Del t is multiplied with f, this with this by cross multiplication. This is the relation for impulse. So impulse is equal to this. Thank you, students. Today we studied about the motion, Newton for force, motion, displacement, Difference between distance and displacement, velocity, types of velocity, graph of velocity, Newton first law, second law, third law, example, momentum and impulse. Tomorrow topic is collision. So thank you students. Wish you best of luck. Allah Hafiz.